Good morning, students. Today we move towards the last topic of the chapter number 11, mensuration. The last topic is volume of a cylinder. So for the revision sake, we have done the total and lateral surface area of a cuboid, of a cube and of a cylinder. In the last two lectures, we saw the volume of the cuboid and the cube. In this lecture, we are going to move on to the volume of the cylinder. So, as you all know, the volume is the amount of space occupied by a three-dimensional object. So, we derived the formula for the cuboid, which was V is equal to length into breadth into height. One part is the length, one part is the breadth, and one part is the height. So, this cube has six surfaces. The four walls are called the lateral surface. We have revised the formula. The lateral surface area of a cuboid is 2 into bracket, 2h L plus B. How we got this? The lateral surface area is this side and the opposite side, this side and the opposite side. So this one is L into H, that is the front and the back. So total becomes 2 LH. And this side is breadth into height, and the side opposite is 2 times, so plus 2 breadth into height. Taking out 2h common, we get the formula L plus P. So that was the lateral surface area of the cuboid given the formula 2 into h L plus B. The total surface area of a cuboid was given by the formula 2 bracket LB plus LH plus BH, and the volume was given by the formula L into B into H. So I hope you have understood all the formulas so far. In the cube, the length, the breadth and the height all are equal. So all the six surfaces have equal areas. So the lateral surface area, that is the four walls without the ceiling and the floor, the top and the bottom, will give us 4L square. The total surface area is all the six sides taken together, so it gives us 6L square. And the volume is length into length into length, or L cube. In the cylinder, we have the lateral or the curved surface area. In cube and cuboid, we call it lateral. In cylinder, we call it curved surface area. Was given by the formula 2 pi r h. And the total surface area was the curved surface area plus the circular area at the top and the circular area at the bottom, giving us 2 pi r square. And taking out 2 pi r common, we got the formula 2 pi r h plus r. So these are the formula for the curved surface area and the total surface area of the cylinder. In today's lecture, we move on to finding the volume of the cylinder. So let us compare. We know that the volume of a cuboid can be found out by two ways. Volume of a cuboid is length into breadth into height. But what does the length into breadth give us? Length into breadth gives us the area of the bottom. This shaded part here, the area of the bottom is the length into breadth. So length into breadth becomes the area. So area into the height, area of the bottom into the height will also give us the volume. So we can take the same comparison with the cylinder. To find the volume of the cylinder, we can multiply the area of the base into the height. So volume of cuboid is given as area of base, that is capital A, into height, which is L into B into H. So we can write this area of base is L into B, that is A into H. Now the base of the cylinder is in the form of a circle. You can see this, the base of the cylinder is in the form of a circle. And let us say the radius of the circle is r. So what is the area of the circle? Area of the circle is given by the formula pi r square. So in the cylinder, the base is a circle whose area is given by pi r square. And taking the same analogy like the cuboid, we can say volume of cylinder is equal to area of base into height. Now the area of the base is given by pi r square, where r is the radius of the base. So area of the base into height gives us pi r square h. So volume of the cylinder has got the formula pi r square h, where r is the radius of the base and h is the height. Remember, r is radius of base and h is the height of the cylinder. So we have got two things here, a radius and a height. So together this is the formula for finding the volume of a cylinder. So this is the last part of the last topic of the chapter, one last formula to find out the volume of the cylinder. I hope you have understood the formula well. So now we'll try out a few sums. We have to find out the volume of the following cylinders. Now look at the first cylinder. The cylinder is slanted. Here we are given, you can see what is marked here. We are marked, this is the radius, which is given 7. So we took r equal to 7 centimeter, and the height of the cylinder h is equal to 10 centimeter. So you can see what is given to us. The radius is 7. It is shown in the diagram. The radius is 7 and the height is 10. So in the first sum, we'll write down the formula volume of cylinder. So you always begin the sum by writing the formula, that is pi r square h. We will take the value of pi as 22 upon 7. Okay, remember we take the value of pi 22 by 7. In some cases we take it 3.14. Now you must have recalled this pi. We always find the value of pi when we are dealing with circular or curved objects. In the previous lectures we had seen that pi is the ratio of the circumference to the diameter. So we always encounter this pi whenever we are dealing with curved objects. Whose value is 22 by 7. Radius is 7, but it is given r square. So we'll write 7 square or 7 into 7. And the height is given as 10, so I put it 10. 7 ones are 7, 7 ones are 7 gets cut. So 22 into 7 gives us 154. And 154 into 10 gives us 1540. And we'll write centimeter cube. Surface area was in centimeter square, while volume is in centimeter cube. Now the second question, the height is given 2 meters and the area of the base is given 250 meters square. Now since both of them are in meter, like here both were in centimeter, there is no conversion needed. But here we are not given the radius, we are directly given the area of the whole base. So which formula will we use here? Volume of cylinder equal to area into height. Area is given 250 into 2, that is 500 meter cube. So meter square into meter gives us meter cube. Now in both these sums, the units radius was in centimeter, height was in centimeter. Here the height was in meter, the area was in meter square, so no conversion is needed at any place. But in case the sum has radius in centimeter and height in meter, or height in centimeter and radius in meter, then we'll have to convert the units before we can find out the volume. Now let us try a few more sums. Now, the last part of the topic was the volume of the cylinder, or we can say volume of the cube and cuboid. Now we have to find the relation between the two terms, volume and capacity. There is not much difference between these two words. There is not much difference. Volume is the amount of space occupied by an object. So how much space an object occupies is the volume. Capacity refers to the quantity that a container holds. Now if you look at this, a container is usually something which is hollow in nature and you can feel something inside it. So capacity refers to something that is the quantity that a container holds. A bottle of water, yes, when you go to market to get a, or you buy a bottle of water in some railways, in a train maybe, or at a place outside, you will find that a quantity is written on the bottle. 750 ml, 1 liter, 250 ml. So the quantity is mentioned, that how much quantity does that bottle or the container hold. So that is called the capacity of the container. Now how do we relate the volume and the capacity of the container? So we have got 1 centimeter cube. Now recall, what is 1 centimeter cube? 1 centimeter cube means a cube whose length is 1 centimeter, breadth is 1 centimeter and height is 1 centimeter. So a centimeter cube is a cube whose length is 1 centimeter, breadth is 1 centimeter and height is 1 centimeter. Means the volume of this cube is 1 centimeter cube. Now if this cube was hollow and I filled it with water, I filled the cube with water, then how much water could this cube hold? Then the amount of water in 1 centimeter cube is equal to 1 milliliter. So 1 milliliter is amount of water held in a cube of 1 centimeter. Again, what is 1 centimeter cube? 1 centimeter cube is a cube whose length is 1 centimeter, breadth is 1 centimeter and height is 1 centimeter. So 1 centimeter cube is the volume occupied by this cube. But if the cube was hollow and I filled it with some material, say water or oil or milk or whatever, then the amount of material which can be filled in 1 centimeter cube is taken to be 1 milliliter. So 1 milliliter is something which can be filled in a cube of 1 centimeter. So 1 liter, how much is 1 liter? 1 liter is 1000 milliliter. Now 1 milliliter needs 1 centimeter cube. So 1000 milliliter will need 1000 centimeter cube. So we can say 1 liter is equal to 1000 centimeter cube, or 1000 centimeter cube volume will be needed to fill something with 1. Next we have 1 meter cube. What is 1 meter cube? 1 meter cube is a cube whose length is 1 meter, breadth is 1 meter and height is 1 meter. So we have 1 meter cube is length 1 meter into breadth 1 meter into height 1 meter. But 1 meter is 100 centimeters. So we have got 100 centimeter into 100 centimeter into 100 centimeter. That is 1 into 1 into 1 is 1, into 2 zeros, into 4, into 6 zeros. So 1, 2, 3, 4, 5, 6, 10 lakh centimeter cube. 10 lakh centimeter cube is 10 lakh milliliter. Okay, this much milliliter can be held in 1 meter cube. Now to convert milliliter into liter, to convert liter into milliliter, we multiply by 1000. So to convert milliliter into liter, we'll divide by 1000. So this 10 lakh will divide by 1000. 1, 2, 3. 1, 2, 3. So we get 1000 liters. So 1 meter cube is 1000 liters. This is the relationship between volume and capacity. Remember, volume is the space occupied by the object and capacity refers to the quantity that a container holds. Means if the volume is hollow, then how much material can be filled inside the container is called its capacity. Now we look at a few sums to understand this topic in detail. Before we go to capacity, there is another sum here. A rectangular paper of width 14 centimeter. So there is a rectangular paper whose width is given here 14 centimeter. Okay, the width is 14 centimeter, is rolled along its width and a cylinder of radius 20 centimeter is formed. So what is done? Have you understood the sum? You can see this rectangular paper has got two edges. This is one edge and this is the other edge. Both are 14 centimeter only. Okay, so that is a rectangular, 14 on both sides. So we have got edge 1 and edge 2. Now what is done? This edge here is rolled to touch the other edge. So this edge is rolled to touch the other edge. So how do you do that? You can try it out with a piece of paper. Take a piece of paper, roll it till one edge touches the other edge and you will get a cylinder. Now you will see that this length, what was the length we do not know, but this length when rolled over, the total length remains the same. This is the same length. The red color thing is the length. But here it was in a straight line. When rolled over, it became a curve. So we do not know what is the curve. But when rolled over, we formed a circle whose radius became 20. And we have to find out the volume of the cylinder. So the paper rolled formed a cylinder. We have to find the volume of the cylinder. Now we know the radius. On rolling, the radius became 20 centimeter. The height, that was the width of the paper, remained the same, that is 14 centimeter. So we'll directly use the formula, volume of cylinder. So I hope you recall what is the volume of cylinder. What is the formula? Yes, it is pi r square h. Here they have mentioned to take pi as 22 by 7. So we'll take pi as 22 by 7. R square, r is 20. So 20 square is 20 into 20 into h is 40. So 7 ones are 7 twos are. So we got 22 twos are 44, 44 twos are 88, 88 twos are 176 and 0, 1 and 0, 2. So we add two more zeros. So this much centimeter square, cube, is the volume of the cylinder. So in this sum we have got nothing to do, just a paper is taken, rolled into a cylinder, and we have to find out the volume of the cylinder, which we got 17600 centimeter cube. So this is very quite simple sum. Now in the next sum, we have got the same kind of sum, but here we have a rectangular piece of paper 11 centimeter by 4 centimeter. So this time we know the length of the paper is 11 centimeter and the breadth is 4 centimeter. Again the same thing is done. It is folded without overlapping to form a cylinder. So you can see when you fold it, the width remains the height. It has not changed. It is 4 only. But this 11 centimeter, which was the length, is now folded and it still remains 11 centimeter. So the total length of the circular part is 11 centimeter. We have to find the volume of the cylinder. Now, let me write down the formula. Volume of cylinder. So do you know what is the formula for volume of cylinder? Is pi r square h. Pi is 22 by 7. R, the radius is not mentioned. Height is 4 centimeter. So we know the height. We have to find the volume of the cylinder, but in this case, the radius is not mentioned. So we'll have to first find the radius. How do we find the radius? So this length, which was 11 centimeter, is rolled. So here this part is 11 centimeter. Means the circumference of the circle, the circumference of the top part of the circle. Yes, see it again. We have rolled the 11 centimeter to form a circle. So this is the circumference is 11 centimeter. Now what is the relationship between circumference and the radius? We know the formula C is equal to 2 pi r. So we got 2 pi r equal to 11. So r is equal to 11 upon 2 pi. So r is equal to 11 upon 2 pi. So we'll write this 11 upon 2 and pi is 22 upon 7. 7 goes on the top, so it comes over here. We got 11 ones are 11, 11 twos are 22. So the radius is 7 upon 4. So that is what we have to put the radius here. 7 upon 4 into 7 upon 4. 7 and 7 gets cut. 4 and 4 gets cut. 2 twos are 2 11s are. So we are left with 11 into 7, that is 77 upon 2. 77 upon 2 is 38.5 centimeter cube. So the volume of this cylinder is 38.5 centimeter cube. Now what is the difference between this sum and the previous sum? In the previous sum, the paper was rolled, but we were given the radius. We were not given the length. We were directly given the radius, so we could directly make use of the formula. But in this sum, the radius is not mentioned. The length of the rectangular paper is mentioned. That is 11 centimeter. So when I roll it into a cylinder, the total length becomes the circumference. It remains 11. So this time the circumference has become 11. Using this formula, C is equal to 2 pi r. I know the circumference is 11. So using this formula, I first find out r. After I find out the r, I replace the value of r in the formula and then get the answer. So this is not a direct sum like the previous sum. This sum is slightly different from the previous one, but we have found out the answer. So this is the topic of the day, volume of the cylinder. To find it by the method pi r square h, where the R may be given directly or not. So this is the formula. You put the values and you will definitely get the answer. So for homework we have sum number exercise 11.4, sum number 2 and the sums 5, 6, 7, 8. So these 5 sums are for homework. You have to do it in the rough book. In the next lecture, we'll discuss all the sums of exercise 11.4. I want to see how many have tried them on their own and how many of you get the answers correct. So in the next lecture, we'll discuss the sums. Till then, you have know all the formula. So what you have to do is first revise all the formula and do exercise 11.4. I'll see you in the next lecture. Thank you.